This is chapter 9.5, Concept of Limiting Reagent. The definition of a limiting reagent is a substance in a chemical reaction that is fully consumed when the reaction is complete. Essentially, this means that the limiting reagent stops the reaction from continuing because it can't continue without it. Therefore, the product is limited by the substance, which gives it the name limiting reagent. Alright, here's a real life example of limiting reagents. You have 5 hot dogs and 4 hot dog buns. And of course, you know that a hot dog requires 1 hot dog and 1 hot dog bun. So because you have 4 hot dog buns and 5 hot dogs, you're limited by the number of hot dogs that you can make by buns. So you don't have enough hot dog buns to make the 5th hot dog. So in this example, the hot dog buns serve as a limiting reagent because the reaction can't continue because of the shortage of hot dog buns. So now that we know how to identify the limiting reactant of a problem, we're going to find the limiting reagents in different chemical formulas. So if you're given the equation below, 4Na plus O2 is equal to 2Na with a subscript of 2 and then oxygen, find the limiting reactant if 5.45 moles of Na sodium reacts with 4.2 moles of oxygen. It must be noted before you start anything that for every mole of the product 2Na2O, there are 4 sodiums and 2 oxygen being used to complete the reaction. This can be seen on the reactant side of the equation. So you know how much is needed right here on this side. So you're going to take the given information, 5.45 moles Na, and we're going to work on the sodium side first. So for every 2 moles that's being produced in the product side, you're going to have 4 moles Na. So once you multiply this fraction across, so you're essentially multiplying 5.45 by half, you're going to get 2.725 moles of Na2O. So this shows that for 5.45 moles of Na, you will produce about 2.73 moles of Na2O. And then we're going to do the oxygen side. So reacts with 4.20 moles of oxygen. We're going to multiply it by 2 over 1 because for every 2 moles of the final product, there's 1 mole of oxygen. So when you multiply 4.2 times 2, you get 8.4 moles of Na2O. So that shows that once you use 4.20 moles of oxygen, you'll produce about 8.40 moles of Na2O. With that knowledge now, you can kind of compare what you're given at the beginning to how much it can produce. And so we see that Na produces a lot shorter amount than the oxygen. So in this reaction, sodium Na will be the limiting reagent. Even though the chemical equation has more sodium in the reactants, it was still used up quickest because it required more of it. So the limiting reagent in this example is sodium. Okay, problem 3. Identify the limiting reagent if 20 grams of H2 reacts with 2.75 grams of O2 in the following equation. First, you must know that the units are different, so an additional step will be added to convert the grams to moles because the hydrogen is measured in grams and not moles. So we set up the examples like we saw in the last one, but this has an extra step of converting the grams to moles. Put grams on bottom so the unit cancels out, and then you multiply the number of by the number of moles of H2O divided by H2 because H2 is on the reactant side, it'll be in the denominator. And you do the same thing for the moles of oxygen, except for you skip the part of the conversion from grams to moles. And you see that the 20 grams of H2O creates 9.90 moles of H2O, and the 2.75 moles of O2 creates 5.5 moles of H2O. So in this reaction, oxygen produces less water than the hydrogen, therefore oxygen is the limiting reagent. and that's chapter 9.5, concept of limiting reagent.